This is the screencast for section 3.7, example 1. Implicit differentiation. Now, the word implicit means implies, and I kind of think that that is related to the fact that you've been doing this all along. Okay, let me show you what I mean. If you have y equals x squared, in the past we take the derivative and you tell me that dy dx equals 2x. Well, there is an implied differentiation in there that you took the derivative of x with respect to x, which we all know is 1. The derivative of x itself, kind of like the chain rule, would say take the derivative of x and it's 1, or dx over dx is 1. The derivative of y with respect to x is not 1, and that's why that symbol stays there. Well, now we have to do that in our functions. Example 1 says find dy dx if y squared equals x. Okay, so we can now take the derivative of y. So the derivative of y is 2y to the first dy dx. So I had to take the derivative of y with respect to x. Equals, now the derivative of x is just 1, then I have to do dx dx. Now, you're right. This is 1 and we don't have to write that anymore. So in my next step, I'll say 2y dy dx equals 1, and now I'm going to solve for dy dx because my instruction said find dy dx. So dy dx equals 1 over 2y. That is an expression of y. Now what you could have done is right off the bat said, okay, y squared equals x means y equals plus or minus the square root of x. Well, then that is y equals plus or minus x to the 1/2. So the derivative of both sides would be dy dx equals plus or minus 1/2 x to the negative 1/2, which means dy dx equals plus or minus 1 over 2 square root x. Well, by definition, y equals plus or minus square root x. So the plus or minus and square root x get left out, and I have 1 over 2y, the same that I got as in doing implicit differentiation. Let's try another one. Number 3, y squared equals x minus 1 over x plus 1. Find dy dx. Okay, so I'm going to take the derivative of the left side, 2y dy dx, because the implied differentiation does not cancel out an equal 1 there, equals, quotient rule. Alright, here we go. Alright, messy quotient rule, so now let's simplify, because remember it says find dy dx, so we still have to solve for dy dx. And now I need to bring the 2y to the right side, and I'll get dy dx all by itself. So I get that dy dx equals 1 over y parentheses x plus 1 parentheses squared, which means this derivative is both a function of x and y. I would need to know both coordinates, x and y, to get the slope at any point.